Hello class, this is Mr. Hunter and I wanted to give you a brief overview and review of projectile motion and what we've done so far. What I encourage you to do is take out your notebook, and this is a video so you have the ability to pause it at any point in time and capture notes or understanding. What I'd like you to do is take notes and then bring them into class with any questions that you have so that we can answer them there. So in projectile motion, we have a few concepts that we went over in class. There's certain demonstrations and such. And the one that we'll really be analyzing right now is a situation, it's a situation where a ball is simply just thrown straight up in the air and caught. As you remember in class, we analyzed a ball that was thrown up at 40 meters per second, and we analyzed that situation and what happened over time. From those notes, we learned a few things about projectile motion. In particular, the velocity in the y direction is 0 at maximum height. And this is true in all projectile situations. Whenever an object reaches the maximum height, we know that its velocity in the y direction is 0. And that's really important. In a frictionless system, the initial velocity in the y direction is actually equal to the final velocity in the y direction, but in the opposite direction. So for example, with that ball that's being thrown up at 40 meters per second, when it gets back to the same point, which is my hand, it is going at a negative 40 meters per second. The time up equals the time down, assuming that start height and end height are the same. Velocity in the x and y direction are independent from each other. This means that they do not affect each other at all. So for example, if I want to know how far something goes, like I throw it to the side, I need my velocity in the x direction. I also need to know how long it takes to hit the ground. However, if I want to know how long something takes to hit the ground, like when I drop this ball, I need to know my initial velocity in the y direction, as well as the height from the floor, because the acceleration due to gravity is going to pull it to the ground. Velocity in the x direction does not change because there's nothing causing it to accelerate or decelerate. And this isn't a frictionless system. When I'm actually in the real world, I do have a deceleration, and that is called air friction. And air friction will actually push against the velocity of my ball, slowing it down. This means that there's no acceleration in the x-axis. So if I shoot a projectile going that way, at each second that it travels for, it is traveling in the same x velocity. Velocity in the y direction, however, is affected by the acceleration due to gravity. It can only affect the velocity in the y direction. And on Earth, the acceleration due to gravity is negative 9.8 meters per second. Now that negative is technically relative, because if you say that up is negative, then that number turns positive, as we'll see in some examples later. And lastly, because all objects fall at this acceleration due to gravity, the velocity on the x-axis does not affect how long it takes to get to the ground. This means that we use variables on the y-axis to determine how long an object is in the air. So for example, and you guys have seen this in class, if I were to drop this ball and shoot this Nerf gun at the same time, they would hit the floor at the same time, assuming that my projectile is parallel to the ground, because I have no initial velocity in the y direction. So let's apply that to the situation that we talked about earlier, when we're launching a ball straight up in the air at 40 meters per second.